All right, let's draw the Lewis structure for formaldehyde, which is CH2O. All right, carbon. Well, first step, let's count up all the valence electrons we have available. So carbon has 4, hydrogen has 1, and we're going to multiply that by 2 because there are 2 hydrogens in this molecule. And oxygen has 6 valence electrons, so that's going to total up to 12 total valence electrons. All right, hydrogen is never the central atom because it can only make one bonding pair. Between carbon and oxygen, which one is less electronegative? Well, oxygen is the second most electronegative element behind, it's the second behind fluorine. So we need to put carbon in the center, and we'll put the other 3 atoms surrounding it. All right, we need to have a bonding pair between each of those terminal atoms and the central carbon. So that's going to take up 2, 4, 6 of our electrons, and we're going to have 6 remaining. All right, the hydrogens they've achieved the octet. So let's move over to our the other terminal atom left is the oxygen, and put the remaining 6 on that to give it the octet. All right, so we've used up all our electrons, valence electrons. All right, all the atoms except for the central carbon has achieved the octet, and carbon needs 2 more electrons, and we've run out of electrons. So what we can do is use a lone pair from the terminal atom, in this case the oxygen, and make a multiple bond using those electrons. All right, so what we get here for the Lewis structure for formaldehyde is this. Now, hopefully you've tried this before looking at the answer, and you may have gotten a different structure. So there's another possible structure that appears correct. So we'll do that here in a different, we'll do that here in different color. You may have tried to put carbon and oxygen both as central atoms and then put the hydrogens around it, and you'll see this appears to be a good structure as well. So let's start with our original 12 electrons, and we're going to put a bonding pair between each of these outside hydrogen atoms and the central carbon and the oxygen, and that's going to use up 6 of our electrons. We're going to use the remaining 6 to put some valence electrons around the carbon and the oxygen, and so now we've used up all our electrons. And similarly as before, all the atoms have an octet except for carbon. So just like we did before, we can take a lone pair from the oxygen and make a multiple bond. In this case, a double bond. Let me make that straighter. Between the carbon and oxygen. Now that looks like a legitimate Lewis structure. All right, let me erase. Okay, so which one is the answer? To find that out, we need to take a look at the formal charge. All right, so the formal charge is the charge on each atom in the molecule, and so we can get that by taking the valence electrons, the number of valence electrons in its neutral atom, and subtracting the number of dots, which are the electrons, minus the dashes, which are the bonding pairs. All right, so let me dashes, not dots, but dots. Okay, so let's take a look at this version, this Lewis structure up here. And the formal charge on hydrogen is 1. Hydrogen has 1 valence electron minus, there aren't any dots, but there is 1 dash, so 1 minus 1 is 0. So this one's going to have a formal charge of 0, and so is the one over here. Okay, the formal charge on the carbon is going to be 4. Right? It has 4 valence electrons, minus the 2 dots, minus 3 dashes. So that's going to be 4 minus 2 minus 3. That's negative 1. So the formal charge on that carbon is going to be negative 1. And the formal charge on the oxygen is going to be 6 valence electrons minus 2 dots minus 3 dashes. All right, so that's going to be positive 1. So the formal charge on the oxygen is positive 1. So that's not looking good right now. All right, we'll do the same thing down here in the lowest structure we made previously. So the hydrogens are going to have a 0 formal charge because 1 minus 1 dash is 0. The formal charge on the carbon is 4 minus 4 dashes. There are no dots. So that's a formal charge of 0, and the formal charge on the oxygen is 6 valence electrons minus 4 dots minus 2 dashes. So 6 minus 4 minus 2 is 0. So every atom in the lowest structure at the bottom has a formal charge of 0. So therefore, this is the best lowest structure for formaldehyde.